So we're in lecture 5 with math 410, elementary algebra. And here is the first section we're doing today. We're doing 4.4. We're adding and subtracting like fractions, least common denominator, and equivalent fractions. So the main component we're going to mess with is LCD. So I'm going to give you guys about 4 minutes to set this up in your notebook, and then we'll get started. All right, guys. So the definition of least common denominator, or also known as the LCD, is actually the smallest possible number that is divisible by all the denominators in the list. But we can also call it the least common multiple, which is the LCM. Now, there's a couple methods we're going to go over in today's class about how to find the LCD. So the method one is finding pretty much using the multiples of the largest number. Step one, write the multiples of the largest denominator, starting with the number itself until a multiple common to all denominators in the list is found. Step two, the multiple found in step one is the LCD. Now, what's one thing to have the method written down, it's another thing to implement it itself. So before I move on to the next slide, just making sure, is everyone good to go before I move on?
No, I'm still copying.
I'm only going to give an additional 2 minutes and moving on.
Okay, thank you.
All right, guys, if you're not done, go ahead and take a picture of this slide or screenshot it from your device. I'll give you a few seconds to do so. I see some students logged on late. So if you logged on late, make sure you take a picture of this screen so you know what to work on. All right. Well, here's an example, guys. Here's example A and B. So we're gonna go ahead and focus on A first. So I'm gonna go ahead and give you a good 2 minutes to set it up. So we're gonna implement the first method right now. All right, look at example A. Find the LCD of 7 and 14. It said to get the largest one first in the first method, right? But I actually like to include both of them, 14 and 7. So you want to go on multiples of these numbers. So the multiples of 14 is just adding 14 to itself until we get the next one. So 14 plus 14 is 28. So that'd be the next multiple. And then we have the sevens. We'll go by multiples of 7, which is 7, 14, 21, and 28, right? So these are all the multiples. Now look, do y'all guys notice any commonalities? Are there any factors, or not factors, but multiples that are similar?
Yes.
Yeah, we have the 14s, but we also have the 28. But so these are both common denominators, but with the LCD, there's a key word in this phrase, the L. What does the L stand for? We want the least, right? So the LCD is 14. And we're done. All it wanted us was to find the LCD. All right, let's look at B. B is find the LCD of 12 and 20. Of 11 over 12 and 7 over 20. So let me switch up my colors. So we're gonna have 20 and 12. So multiples of 20. So 20, 40, 60. We want to keep going until we think we can find one for 12, right? But if you're not really good with numbers, you're going to do multiples of both numbers until you see some that are matched up. Okay. So I'm going to stop at 16 and then I'm going to go on 12 now. So 12 and 12 is 24. 24 and 12 is 36. 36 and 12 is 48. 12 and 48 is 60. And right there, we found our first common denominator, and it's 60. So that is how you find the LCD of fractions. Are there any questions on the steps that we took? All right. If there's no questions, guys, let me go ahead and pull up to the next slide. Now you guys are going to go ahead and practice, all right? Good luck. I'm going to give you 3 minutes to practice. Or 4, I'll give you 3 minutes. I'll add a minute if we need more time. Good luck. All right, class. So that was the 3-minute timer. Anyone still working on these practice problems? All right, what was the LCD for the first one, guys?
Is it 32?
For the 8 and 16?
Yes.
Is that the, remember, LCD, is it the least common denominator? Is it the least one?
16?
16. Okay. Do you know why it's 16 over the 32 though now? That it's smaller though, right? That's the only reason.
Yes.
Now, okay, good. What did y'all get for the second pair? So the first one is 16, guys. So if you got 16, good job. If you didn't get 16, you want to ask me why it's not what it was, let me know. All right. What'd y'all get for the LCD for the second pair of fractions?
150.
150. It's anyone got something different? If you got 150, guys, good job. Now, if you didn't get 150, would anyone need me to work these problems out before I move on, guys? Anyone?
Can you work out the first one?
Of course. So we have the 8 and the 16, right? Well, I'm gonna go 16, 32, right? For just the second one. And then we have 8, 16, 24, and 32. Notice that there's two common denominators at this point. We have the 16 and we have the 32. But remember, it's not asking for all common denominators, it's asking for a specific one. It wants the LCD, the least common. And least, which one's least or less than the other one? This one is 16. So therefore, this is the LCD. 32 is a common denominator, but it's not the lowest one. It's not the least one. That's why 16 takes the cake for this one. What questions do we have so far? Does anyone have any questions or need me to do the second practice problem? Are we okay, guys? All right, let's go ahead and move on. There's going to be a second method, guys, which involves prime factorization. I'm going to give you guys 3 minutes to set up this slide in your notebook before I move on. I'll do 4 minutes just to be safe. All right, see you in 4 minutes. All right, guys, for 4 minutes enough for you to say, get down these steps and this recall. All right, method 2, finding the LCD of a list of denominators is using prime factorization. So for step 1, you're gonna write the prime factorization of each denominator. And then from there, you're gonna, for each different prime factor in step 1, you're gonna circle the greatest number of times that factor occurs in any one factorization. Step 2 is the key to using this method. Step 2 is very important. Oh, actually step 1 and step 2, because you need to write the correct prime factorization, right? Step 3, the LCD is the product of the circled factors. So recall, a prime number only has factors of 1 and itself. So here's the example of the first 6 prime numbers: 2, 3, 5, 7, 11, and 13. Since the only factors of each of those numbers is 1 in itself. All right. Now, before we break down, let's go ahead and look at the next set of example. We have 72 and 60. Find the LCD of 72 and 60. So before we do that, we're going to be breaking down 72 equals, and we're going to be breaking down 60 equals, like the prime factorization, okay? Now, before we do that, I'm going to show you how to do a factor tree. A factor tree is kind of like the safest way to do to find the prime factorization of any number. So the first thing, you put a circle here on 72. Make sure you have enough space because we're going to be going down like a web. So remember, the smallest prime factor is 2, right? So 72 is the same thing as 2 times 36, right? And every time y'all get into, actually, you don't even have to circle 72. I don't think you do. It's been a while since I've done a prime factor tree. Okay. So since 2 is a prime, guys, we're gonna circle the 2 because it's a prime. Because remember, right? 2 times 36 is 72, right? But guess what? 36 can be broken down by another prime, right? It can be broken down by 2. It could be 2 times 18 to give me 36. So this is another prime. 18 is the same thing as 2 times 9. And 9 is the same thing as 3 times 3. And 3 times and 3s are both primes. If it's in that list, that and this list over here, you're gonna circle it, guys, when you get there. So 72 is the same thing as, let me scroll down a little bit, is the same thing as 2 times 2 times 2 times 3 times 3. 2 times 2 times 2 times 3 times 3. And now if you want to show that it's 72 on your, get your calculator out that you have. And I'm gonna do it. I'm gonna do it on my calculator to just show myself. 2 times 2 times 2 times 3 times 3. And I got 72. Let's go ahead and do 60 now. Let's do 60. Switch off my colors. 60. So now notice how 60 can, 2 and 3 can both go into 60, right? 3 times 20 and 2 times 30. Those are the same ones. Let me tell you right now, it doesn't matter which one you start with. Eventually, that 3 is going to come out if you start with the 2. That 2 is going to come out if you start with the 3. Anyone tell me, which one would you want me to do? You want me to do 2 times 30 or 3 times 20? And when you do the factors, it's always important that one of them is a prime number, though. It has to be 2 or 3. What numbers multiply give me 60, everyone? Where the prime numbers included? So 60 can be broken down to 2 and 30. 2 times 30 is 60. 2 is a prime number. 30 can be broken down to 2 and 15. 15 can be broken down to 3 and 5. And these are both prime numbers, so we're done. So this is gonna be the same thing as 2 times 2 times 3 times 5. Now, step 1 is done. Step 1 is write the prime factorization of each denominator. Check, we did that. Now, for each different prime factor in step 1, you're gonna circle the greatest number of times that factor occurs in any one factorization. They both have 2s, they both have 3s, but only 60 has 5. So let's go ahead and circle. Which one has more 2s, the blues or the reds? Well, the blues, right? So it wants the greatest numbers you see a factor there. So we're gonna circle those 3 because this has more than the 60. Look at the 3s. There's only 1 3 here and 2 3s here. So I'm gonna circle this one because it has the most 3s. Now this is the only one with the 5. So you wanna make sure you're circling one set of each prime factor. So this is the 2s over here, the 3s over here, and then the 5 over here. Now to find the LCD, guys, this is where you're gonna get mind blown right now. To get the LCD, you're gonna multiply all the ones we circled. So the LCD is gonna be 2 times 2 times 2 times 3 times 3 times 5. And when you multiply this, that's gonna be your LCD. So it's gonna equal to 2 times 2 is 4, times 2 is 8, times 3 is 24, times 3 is 72, times 5, 72 times 5 is 72, 360. And we're done. Any questions on how I did the prime factorization tree? Any questions on how I wrote them afterwards? Any questions on how to find the LCD? You have the steps. You have me showing you the steps. Are there any questions before I give you the practice problem?
What was that negative there again?
Don't worry about the negative. That negative just means this fraction is negative. That's it. It's not gonna change the denominators. All right. Here is your practice problem, guys. I'm gonna go ahead and start off with giving you 3 minutes. All right. Good luck. All right. Does anyone need more time? What did y'all get? Do y'all need more time, guys, or what did y'all get?
216.
216. Did anyone get something different? 216 is not correct.
Can you go over this one?
Sure thing. Just trying to see if anyone else got something different. All right. So the first thing you want to do is you want the prime factorization of both these numbers, which we don't have, which we have to obtain using the prime factor tree, which is the technique I know. So we start off with 40. 40 can be broken down to two factors. Which ones, guys? Y'all tell me, because this is a practice problem.
4 times 10.
4 times 10. Now, are any of these prime, Sarah?
No.
So that means they both can be broken down. 4 can be broken down to what?
2, 2.
2 times 2. They're both prime, so you can stop here with the 2's. Everyone see that part?
Mhm.
Good. Look at the 10. What can the 10 broken down to?
2 times 5 or
2 times 5, yeah. And those are all primes. So then this is going to be 2 times 2 times 2 times 5. All right, let's do 108 now. What two numbers can this multiply to?
12 times 9.
12 times 9. All right, now let's break down the 9. What can 9 be?
3 times 3.
Yep. And those are both prime, so we can circle those. Now 12, how can we break down 12? What are factors of 12? What two numbers multiply?
4 times 3.
4 times 3. This is also a prime. 4 can be broken down to what? 2 times 2. So now we have our thing. We have 2 times 2 times 3 times 3 times 3. Now remember step 2, guys. Step 2 is wants us to, for each different prime factor, we want to circle the greatest number of times that they occur in any one factorization. So we're not gonna circle the 2's here and the 2's there because they're different, they're the same ones. We have to circle the ones where we see them the most. So let's look here. We have 1, 2, 3, 3 2's and 2 2's. So which 2's am I gonna circle? The 40 or the 108? Remember, it's a practice problem, so I need y'all to tell me.
Only
the 40.
From the 40, because there's 3 of them there. Now, which other factor am I gonna circle from where?
from the 108 the trees.
Yeah, I'm gonna circle the 3's here because it has the most 3's. And then do you see any other prime factors that are not 2 and 3? Yeah, the 5. So then you're gonna get the LCD is 2 times 2 times 2 times 3 times 3 times 3 times 5. Go ahead and multiply that in your calculator and tell me what you get. Let me look at the chat real quick. Valishka and Kayla, they got 1,080. That's what you should have gotten.
But why do we put the 5 again?
Because it is very important that you include every different prime factor that is shown, even if it's one time. The reason why I circled it here is because is there a 5 in 108? No, right? So we want to make sure, look at the step, read the step again. It says for each different prime factor, different prime factors, and these are all different primes. So if you, every time you see these numbers in your prime factorization, you want to make sure you circle the greatest amount of times that factor occurs in any one factorization. So in this one here, the 5 was only here once, but it was still here. So we have to include it in the calculation. We have to include it. That's the one that you didn't include, right? That's why you got 216, Sarah, because you didn't put the 5 in there.
Oh no, that wasn't me.
Oh, wasn't you? Someone else? Oh, okay. But
So you only the ones that have like 3, like 2 times 2, or the 3 times 3 times 3.
those are the only ones you had.
What if it was just 2 and 2 and then 2 and 2 on the top? Like, was that possible?
Like they're both the same pretty much. Yes, if you have the same amount of prime factors, and let's say it was 2 2s and 2 2s here, just circle any one of them, but you cannot circle both.
Okay.
So yeah, so that's a great question. If there's both the same amount, you just circle either one, okay? It wouldn't matter. Like, let me show you what I mean by that. Let me include a page here. Insert page. So like, for example, let me give you these two prime factorizations. So we had 2 times 2 times 4. Oh, no. Times 5. And then we had 2 times 2 times 7. This is going to be 20. And this is going to be 28. Well, notice how they both have 2, 2 here, right? Well, it doesn't matter which one we do. We can just circle this one. And then this is a 5 and a 7. So it doesn't matter which one we circle if they're the same, as long as we circle one of them. And then the LCD for 20 and 28 is going to be 2 times 2 times 5 times 7, which is 140.
Thank you.
No, anytime. Let me give you about a minute to copy this extra example down. 'Cause that's a great question. What if they're the same, right? And there's this helpful hint to kind of help you write down into words the question that was just asked about if there's the same number of factors. I'm gonna go ahead and give you guys about 3 minutes to write this down. Anyone need additional time to copy down this helpful hint, guys? Anyone need additional time? All right. Here is the next two examples, guys. Let me give you guys about 2 minutes to copy the first one, A, down before we move on. Before I start working it out, 2 minutes. All right, guys, so we have 15, 18, and 54. We have to do the prime factorization for 3 different numbers. So it'll be, we're gonna have 15, 18, and 54. We'll start out with 15. 15 is pretty easy. What 2 numbers multiply that give me 15?
5 times 3.
Yeah, 5 times 3. And they're both prime, so we can just write 3 times 5. They're both prime. All right. 18. What numbers break down 18?
9 times 9.
What was that?
2 times 9.
2 times 9. And then 2 is a prime, but 9 isn't, which is just 3 times 3. So there we go. So that's 2 times 3 times 3. So now we finish 15, we finish 18. Let's do 54. All right, so 54. Help me out, guys. How would you break down 54?
9 times 6.
9 times 6. Now, how would you break down 9? Oh, we already know that,
3
right?
times
It's,
3. Yeah.
yep. And how do we do 6?
3 times 2.
Yep. And those are all the primes. 2 times 3 times 3 times 3. All right. Let's look at the different primes. Let's start with 2. Which one can we circle? Does it matter which two we circle? Does it matter?
Not this time because it's only one.
There's only one, so it only does not matter. So we did the twos now. Now, which threes has the most threes? The 15, 18, or the 54?
Before.
So we circle these threes. And then any other primes I'm forgetting to circle?
A 5.
The 5, good eye, good eye. So now that we know the LCD is gonna be 2 times 3 times 3 times 3 times 5, which is equal to 6 times 5 is 30 times 3 is 90 times 3 is 270. And we're done. Any questions on how I did A? Any questions whatsoever? All right. B is a lot easier, guys. B is slightly easier because the denominators are 5, x, and x cube. Well, 5 is just 5. We cannot break it down, right? Because it's a prime already. X is just by itself, so we can just leave x alone. And x cube is x times x times x, right? Actually, I meant to do this in blue. This is 5, this is x, and this is x times x times x. So now we gotta circle each prime that we see. 5 is by itself. And then we see there's 3 x's here. So now let's get the LCD. So the LCD is every prime, the most that we see, right? So it'd be 5 times x times x times x. So the LCD is just 5x cubed. And we're done. What questions do we have here before we move on, guys? What questions? All right, anyone need an additional time to copy down B before I move on? All right, I'm about to give you your last set of practice problems for this lesson before we move on to the second section, guys. All right, here's your last practice problem for today's lesson. I'm gonna go ahead and give you guys about 4 minutes to start with, 4 minutes. Good luck. All right, that was my timer. I see in the chat, Sarah gave her responses for 1 and 2. Does anyone agree, disagree? Excellent, Jean. Okay, good, 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 sir. All right, let me go ahead and show you the answers. So the first one is 120 and then 11y. Does anyone have any questions on how to do it? Any questions, comments, or concerns on the first lesson, everyone? All right. And now we go ahead and we're gonna solve by multiplying the LCD. So solving equations with fractions, 4.8, guys. I'm gonna go ahead and since we finished the first lesson, I'm gonna give y'all we're gonna have our 10-minute break, and then I'm gonna add 3 minutes to let you write on here. So in 13 minutes, make sure you have this slide written down and ready to get started, guys. 13 minutes, okay? Enjoy your break, use the restroom, stretch your legs. I'll see you on 13 minutes. All right, 4.8, solving equations with fractions. So example, solve by multiplying the LCD. So we have two different denominators. We have 4 and 8. Now, what is the LCD? Remember, there's two ways to find it. Listing out the multiples or doing the prime factorization. I'm just gonna do the multiples of this one. It's pretty simple. We have 8 and 4, 4 and 8. So 8 is the LCD. So LCD is 8. Right? So the way you solve this is we want to get rid of the fractions, right? So the way you do that is we're going to multiply the LCD for these fractions on both sides. So we're going to have 3/4 x equals -1/8. And we're going to multiply the whole thing by 8. So when I put the whole equation in brackets, we're going to distribute this 8 to the left side of the equation, to everything in the left side, and to everything in the right side. So that we're going to get 8 times 3/4x equals 8 times -1/8. So we're going to go ahead and keep multiplying it across. So we have a whole number and a fraction. So you're probably wondering, well, what happens with the whole number and fraction? Well, there's a lot of things you can do this. You can simplify before you multiply, like 8 and 4. 4 goes into 8 twice and you cancel things out. You could do that, but I don't want to confuse you by that method. So I'm just gonna multiply it out. This will be the biggest bet for you. So I'm gonna make 8 into a fraction, everyone. To make 8 into a fraction in mathematics, you put it over 1, which is what I did, and then you multiply across. 8 times 3 is 24. 1 times 4 is 4x. 24 divided by 4 is 6x. Make 8 into a fraction here. 8 times -1 is -8. 1 times 8 is 8. So -8/8 is equal to just -1. Now we're almost done. We want to get x alone, right? That's the objective here. So we divide both sides by 6. So then the solution is x equals to -1/6. And yes, you can check it by plugging it in, but it's not asking us to check, just wants us to solve. Any questions on the steps that we did here? Now, let me show you the other thing, what I meant, like when I say I could simplify it, right? So you know how we have the 8 on top and the 4 on the bottom and stuff? How can they simplify? Well, we know 8 is the same thing as 4 times 2, right? Well, guess what? When we have a 4 on top and the 4 on bottom, that cancels out. And we're left with 2 times 3. And 2 times 3 is 6x. Y'all see that? How we get the same thing. Now over here, the 8s can cancel out and we're left with -1, which is what we had over here. Any questions so far? All right, let's look at B. The two denominators we have is 6 and 3. The LCD for that is 6. After a while, you can start seeing things quicker. You can start seeing things better. The LCD is 6 because 6 goes into 3 and 6. So I'm going to multiply the whole thing by 6. I'm going to write the question x over 6 plus 1 equals 4 over 3. I'm going to multiply 6 to all of the terms in the left side and the right side too. We're multiplying the whole equation by 6. So then we're going to get 6 times x over 6 plus 6 times 1 equals 6 times 4 over 3. All right, let's simplify together, guys. Can y'all tell me what happens to the 6's right here with the x over 6? Anyone? What happens to my 6's? If we have one on top and one on bottom, they're going to be canceled out, everyone. So then this becomes, we just get x here. 6 times 1 is just 6. And over here, 6 is actually 3 times 2. So the 3's are going to cancel out. And we're left with 2 times 4, which is just 8. Now, if you didn't want to do that, you can make 6 into a fraction and do 6 times 4 is 24 over 3, which is still 8. Go ahead and solve for x, guys. We're going to subtract 6 on both sides. So then we get x is equal to 2. And we're done. What questions does anyone have on how to solve equations using the LCD? It's much easier to do the LCD than to just subtract and multiply fractions and whatnot. Like there are other ways to solve this. I'm showing you the LCD way. This is to get rid of fractions in your life. Notice how we started off with fractions everywhere, and then we got down to x plus 6 equals 8. That does not have any fractions, and that's something we know how to solve. Then you have the one on the left equation. We got 6x equals -1. That's another equation we know how to solve, as opposed to the original equation. So it's an important skill set to have, and it's cool that you get to learn it in this class, is how to get rid of fractions from an equation. You pretty much just multiply the LCD. All right, here are some practice problems for you to try on your own. I'm gonna go ahead and give you guys 4 minutes to work through these. 4 minutes. Good luck. Hey, does anyone have any question on these practice problems? What did y'all get? Were you able to find the LCDs and multiply things out and solve for X? So if you got -9, 11 for the first one, you got it correct. And if you got 10 for the second one, you are on the right track. Does anyone have any questions for me on these practice problems before I move on?
Can you go over them?
Sure thing. All right, I'll go. Like I said, practice problems I can discuss as long as it's student led, not just me teaching it again because I did the examples already. So for the first one, what did y'all get for the LCD for the first equation, guys? You have two fraction denominator, 15, yeah. 15 is the LCD. So we're gonna multiply 15 to 11 over 15, x equals -3/5. So we're gonna distribute that to both sides. So then we get 15 times 11 over 15x equals 15 times -3 over 5. What happens on the left side with my 15s, ladies and gentlemen? What happens?
We cancel.
They cancel out. So then we're left with 11x. And now we have the right side, 15 -3 over 5. Now, how would you simplify this? There's more than one way to simplify this. How did y'all do it? How would you do this?
Hold on, sir. Going a little bit too fast.
Well, it's because it should have been worked out. So that's why I'm just my bad. Notes I can slow down, but practice I'm just into it because yeah, it should be worked out already. All right, look at the right side, guys. We have the 15 times -3 over 5. So if you don't know how to simplify where like 5 goes into 15 three times, the 5s cancel out, you're left with the 3 times -3. Then don't worry about that component. Then you can just multiply across. But remember, 15 is just 3 times 5, right? You have a 5 and a 5, so these 5s can cancel, and we're left with 3 times -3, which is -9. That is one way we can do it. But let's say you can't see the numbers and factors like the way I can, and you guys are students, right? Well, you know how to make it into a fraction, right? 15 over 1. Then at that point, if you can't break down numbers, then if you can't beat them, join them. Just multiply them. Then you make it into a fraction over 1, and then you multiply the top with the top. 15 times -3 is -45. 1 times 5 is 5. So divide that out, and then we get -9. 11x is equal to -9. Now, if we want to get x alone, we know we're multiplying the 11 and x, so we're going to go ahead and divide both sides by 11, and therefore x is equal to -9 over 11. And we're done. All right. I was asked to go over both, so this is the first one. Go ahead and switch up my color for the second one. Now, before I jump onto the second one, do we have any questions on any of the steps that I took for the left side? All right, let's look at the second one, solve. Can someone tell me what the LCD is for these two fractions? 4 and 8. LCD. What is the least common multiple or least common denominator for 4 and 8, guys? 8, yeah. If you got 8, good job. It is 8. So I'm gonna multiply 8 to the whole equation, y over 8 plus 3/4 equals 2. I'm gonna multiply 8 to all of these terms. So it'll be one arrow here, this arrow here, and then an arrow to the right side with a 2. We're gonna multiply this across. So it's gonna be 8 times y over 8 plus 8 times 3 over 4 equals 8 times 2. And now let's simplify this out. Let's see how it works out. What happens to the first fraction? 8 times y over 8. What happens to my 8s, ladies and gentlemen? And we're just multiplying it out now, so I'm gonna need y'all to help me simplify. What happens here in the first fraction? 8 times. Excellent. We're left. What are we left with?
Y.
Correct. Good job. Good job. Okay. Now we're on this fraction here. Now remember, if you can't simplify, you can just multiply them when you make it into a fraction over 1. What does this become? 8 over 1 times 3 over 4.
So do you do just 8 times 3?
And what do you get for that?
24?
And is that going to go on the top or the bottom of the fraction?
The top.
The top, good. And then what goes on the bottom?
I don't know, 8?
What? So remember, you did 8 times 3 to get the 24, right?
Oh, okay.
So how do we do the bottom? What's
1 times 4?
which is what?
4.
Correct. And does 24 over 4 simplify? Plug that into your calculator. See if you get 24 divided by 4.
6.
Yeah, good job. So then the next step would be y plus 6 pretty much, right? It's the same thing. And now the next step, what's 8 times 2?
16.
Correct. So we still need to solve for y. We have the equation y plus 6 equals 16. How do I get y by itself? I want to get y by itself. So how do I move?
6.
There you go. What we do to one side, we do to the other. So then we get y equals, what's 16 take away 6?
10.
And we're done. Thank you for your assistance. Does everyone see that, guys? What questions do we have on the steps that we took? Yes, it may be confusing sometimes, but this is what's beautiful about the LCD when you have fractions in your equations. It takes away the fractions and it makes it easier to solve. And now at this point, after this lesson, you should start noticing that you are gonna start having fractions as answers now. Like in the other lessons, all the solutions were always whole numbers, okay? Now it's not gonna be the case anymore. Fractions are free game. So be on the lookout as you work through your equations on the assignments. Any questions here before we move on, guys? Any questions? All right, let's keep going. So these are the steps added. So we have steps 2 through 5 already. The only thing that's new on this slide is step 1. If fractions are present, multiply both sides of the equation by the LCD of the fractions. Everything else is the same steps as before. But I'm gonna go ahead and give you about would anyone like to copy this knowing it's the same as before with just one added extra step? Would you like to have this as a resource in your journal? I was just putting it here to show you, hey, the steps are still the same, but now we have to, if fractions are around or present, we have to multiply both sides by the LCD so we can get rid of the fractions and we can keep moving forward with the regular steps. If you guys would like to write this in your notebook, let me know so I can give you time to write this.
Yes.
Okay. Go ahead and give you guys about 5 minutes. I think 6 minutes. Last time I gave 6 minutes. All right, good luck. All right, guys, that was a 6-minute timer. Anyone need additional time for this slide? If you need a class or came in late, take a picture. Everyone else, are you good to go? Okay, I'll take the silence that we're good. All right, here we have some more examples, guys. Now the LCD isn't very too common. Now we have two different things, two different numbers on what to do. Let's find the LCD first, right? That's our goal. So we need to find LCD. So to find the LCD, we have these two numbers. We have 5 and 3. So we're gonna do the multiples of these. So 5, 10, 15, 20. And then we have 3, 6, 9, 12, 15, 18, 21. I see it there. We have the 15 on both sides. So we're gonna, the LCD is 15. So LCD is 15. Everyone comfortable with how I found it? So now we're gonna multiply 15 to the whole equation. So we have 15 bracket z over 5 minus z over 3 equals 6. We're gonna multiply 15 to all of these. So let me switch up my color. So draw my arrows. It'll be to these two and this one over here. So it'll be 15 times z over 5 minus 15 z over 3 equals 15 times 6. All right, I'm gonna go ahead and make this into a fraction over 1. 15 times z is just 15z. 1 times 5 is just 5. So then we get 5 here. Now 15 divided by 5 is 3z. Over here, we have minus 15, right? Make 15 into a 1 over 1 minus 15 times z is 15z. 1 times 3 is over 3, which is just minus 5z, right? There's five threes and 15. 15 times 6, plug that into your calculator, guys. 15 times 2 is 30. That should be 90. Now let's go ahead and combine like terms. 3z take away 5z. You owe me 5, but you only have 3, so you still owe me 2. Equals 90. And they're multiplying, so we're going to divide by -2. We do on both sides. This becomes a 1. Z is equal to -45, and we're done. What questions do y'all have for me for the way we solve this equation, guys? Any questions at all? Notice how the moment we got rid of the fractions by multiplying the LCD, we had an equation that we can solve on our own without having to freak out or have a panic attack. The LCD is an extra toolkit in your arsenal that you can use to solve equations involving fractions. All right, we're on B, the last one. Let's find the LCD. All right. First, we're going to find the LCD. We have 2 and 3. You have 2, 4, 6, 3, 6. Boom. 6 is the LCD. Once we did the 6, we're gonna multiply that to the whole equation. X over 2 equals x over 3 plus 1 over 2. I'm gonna multiply that 6 across to every term in both sides of the equation. So then we're gonna get 6 times x over 2 equals 6 times x over 3 plus 6 times 1 over 2. All right, that means simplify the left side. So 6 over 1, right? 6 times x is just 6x. 1 times 2 is just 2. 6x over 2 is just 3x. No more fraction.
So you did 6 times x is 6x, and then you did 6 times 2 is 12?
No, no,
Oh,
no.
no, wait. Okay.
You with me? Top with
Yeah.
top, bottom with bottom. If you want to make a little note, you can. You can put when multiplying fractions, times top with top, bottom with bottom. All right. Now let's do this other fraction. 6 over 1, right? 6 times x is 6x. 1 times 3 is 3. 3 goes into 6 2 times, and there's still an x there. 6 over here with 1. 6 times 1 is 6. 1 times 2 is 2. And 6 over 2 is just 3. All right, and now all we have to do is solve for x. So I'm gonna move x's to one side. So since 3x is already by itself, I'm gonna move the 2x over here. So it can be with the 3x. These become 0. 3x take away 2x is just x, 1x or just x. Bring down the 3 and we're done. What questions do we have here so far before you try the practice problems? What questions do we have? Does everyone see that the incentive of finding the LCD, it makes it a little bit easier, in my opinion. A little easier and less likely to get a wrong answer because there's no fractions involved in your solving. All right, let's see how you guys do in the practice problems. Ready? I'm gonna go ahead and give you guys about 5 minutes on these two. Good luck. Alright, guys, that was the timer. What, okay, so for the first one. So for the first equation, what y'all get for the LCD? The LCD,
5.
correct? Now, it's something when you multiply it now, right? You did get the LCD is 5. So let's go ahead and multiply it out, right? How many arrows should there be when you're distributing that 5 to the equation?
3.
There should be 3. You should be multiplying this 5 to all the terms in the equation from the left side and the right side. So when we do that, we get 5 times x over 5 minus 5 times x equals 5 times 1 over 5. What happens to the 5s with the first equation, the first fraction? I mean, it's a practice problem, guys. This is not note, so I'm not explaining this. I need you to explain to me the process.
5 times x,
5 times x, which is what?
5x.
Say that one more time.
5.
5x, right? Okay, good.
Mhm.
Over what?
1.
What? Not just one. Nope. Remember, top with the top, bottom with the bottom.
5.
5. What happens to the 5s when we have one on top and bottom?
Cancels out.
And we're left with just what?
X.
Excellent. So I'm just gonna write X, okay? Because, all right, so this should be just X. Now we have minus, what's 5 times X? 5x equals, now what happens on the right side? 5 times 1 over 5. Well, over 1, right? 5 times 1 is 5. Times 1 over 5, which is 5 over 5, which is just 1. Does everyone see where we get from the LCD to this point, guys? Everyone with me?
Yes.
Now let's combine the like terms. What's x minus 5x? You owe me 5x's, but you only have 1, right? Because this is a 1x.
So before,
What kind of 4?
-4.
Good. So then we get negative 4x equals 1. And how do we get x alone? How do we get rid of the negative 4?
Is it +4?
What's going on with the 4 and the x?
Multiply.
So what do we do? How do we do the opposite?
Divide.
By what?
4. -4.
There you go. So then we get x is equal to negative 1/4. Let's see if that's the correct answer. And it is. All right, let's look at the last practice problem of today, guys. The last practice problem. What'd y'all get for the LCD?
Ten.
Correct. That is correct. So you multiply 10 to the whole equation. How many arrows am I going to include with the when I multiply the 10?
3.
Correct. So then we get 10 times y over 2 equals 10 times y over 5 plus 10 times 3 over 2. All right, let's go ahead and simplify. I'm gonna make these 10s into fractions, right? Because some of us are beginners with numbers and we're not really experts yet. So for the first fraction, the top and the top over the bottom times the bottom. What's the top times the top? What's 10 times y?
10y.
over what?
2.
Excellent. Equals. What about this second fraction? 10 times y over 1 times 5. What should that become?
10y over 5.
Good. And then for the last fraction, what do we get?
15.
10 times 3.
Oh, 30 over 2.
There you go. So now let's go ahead and simplify. How many 2's go into 10y?
5 times.
So it's 5y equals 10y divided by 5 is 2y. 30 divided by 2 is 15. Now it's just an algebra problem. How do I get y's by itself? What do I move over?
Subtract the 2y.
Subtract the 2y. This becomes 0. 5y minus 2y is 3y equals 15. How do I get the y by itself?
Divided by 3.
And how many 3's go into 15?
5 times.
And we're done, everyone. Do y'all see the benefits of using the LCD to cancel out the fractions? Is it a process? Is it tedious? Yes. But is it helpful? Yes. What questions do we have so far on today's lessons, guys? What do we have so far? Any questions whatsoever? Okay, guys. Any other questions regarding my lessons from today?
I had a question. So for the LCD,
Mhm.
I thought that we would do like the 5 and the 2, not the 2 and the 5. Oh, it's the same thing, I guess. Now that I look at it.
No, yeah, it is the same. Yeah. But you get it though, right? You good?
Mhm.
Okay, good. Good question though. Now there's multiple, remember, you have the two ways to find the LCD. Like if you're probably wondering, well, how did he get the 10? You know, there's multiple ways to have gotten the 10. You could do the multiples, right? 5 and 2, or you can just multiply them, but they're both prime numbers, right? 5 and 2. And since 5 is just 5 and 2 is just 2, the LCD, remember, you have to circle each prime factor that you see is just 2 times 5, which is just 10. So you can use both methods for this, actually. You can do the multiples or you can do the prime factorization method. Okay. I did want to start on lecture 6 a little bit. But if anything, we can probably just do it. We'll just do it on Wednesday, guys. Since I am giving you an extension of the homework and stuff and the test, I'd rather you guys use the rest of this class time, which is an hour and 45 minutes for you to tackle on the homework. So that way you can have less to do during the week. Since I am gonna dismiss class early, I encourage you guys to use this additional time that you have that I could be using for notes to get ahead of Wednesday's class, but I'd rather you guys actually have some time to work on some of the stuff from the weekend. So I'm gonna go ahead and once I dismiss the meet, I'm gonna